So Unit 2, lesson 2.6, the chain rule part 1. So we're just doing part 1 today. We're going to go to example 4 of 8. So although we've learned to differentiate a variety of functions, our differential rules still do not enable us to find the derivative of the function square root of 2x squared plus 3. We can't do that because there's something inside. Okay, we can do the square root of x because we can just make that x to the 1/2. Well, we could just make this 2x squared plus 3 to the 1/2, but you can't ignore that the inside is no longer just an x. Okay, and that's kind of what the chain rule is going to deal with today. So notice that if f is a composite function, it can be built up from a simpler function. So square root u equals g of x, we can plug it in. Then we kind of could. But anyways, this is just talking about the composite of just plugging in how it would work and how it wouldn't work. But the main point that we want to get to is the actual rule itself. So the chain rule is essentially, I think the best way to say it, is the derivative of the outside times the derivative of the inside. So the function of like whatever's on the inside. So you want to take the derivative of what's on the inside and set it out, and take the derivative on what's on the outside. So what that means is, like, we're going to get to it. I know it sounds confusing. Let me give you a quick example. Okay, so right here, this 2x is my g prime. That's the inside. So what's the derivative of 2x? 2, right? Okay, now pretend that this was just like an x. What's the derivative of the whole thing? I would drop the 3, and it would now be a 2. Okay, so you'd have the 3 here. So it'd be 6, 2x, 2. So derivative of the outside times the derivative of the whole thing. That's what I mean by the whole thing, because the chain rule comes from stuff with an exponent in a bracket. So you take the derivative inside the bracket, and then take the derivative of what it would be if this was like a whole function. Okay, that's kind of the idea. I'm trying to find the wording here. Let's chain rule differentiate composite function. We differentiate the outer function and evaluate the inner function at g of x, multiply them by the derivative of the inner function. Okay, and then this is just in Lebanese. It's just going to be same thing with the dy dx's that we've looked at, just the patterns. Again, I like just showing you these because when we get to the points where this stuff gets more difficult, we're going to be using dy dx a lot to help us solve more difficult functions. So just, like I said, just kind of keep that in mind. The du's are the substitutions, like the inside. That's what the du stands for, is like you're making u what you're subbing in. Okay. The way they kind of do it longhand is they say we're going to make 2x be u. Okay. So we're going to go, what's the derivative of u cubed? Well, it's just 3u squared, right? But then by our rules, we have to do what's u prime. That's the inside, 2x, which would be 2. Okay? So it's like you're looking at the inside in terms of subbing it. All right, so let's get to an example here first. You getting lost already? Okay. All right, let's just go to the example here because I don't want you to look through all this stuff right now. So let's go through this. So we want to find f prime of this. Okay? So what we're going to do is I'm going to show you the u, like what I'm talking about. So what would you want your substitution to be? Where would you want u to go? Like what would u be? It's the inside. So u is 2x squared plus 3. Okay, so that's like our u. So then f of u is the actual, we're going to call it root u. Like we're just putting in, we're subbing in the u. So what's the derivative of square root u? We know that. Like what's it? Whoa. Yeah, who's getting everywhere? Okay, square root u. What's the derivative of square root u? Like we did square root x. What's the right? So f prime is 1 over 2 root u, right? By our definition, we also have to do what is u prime. What's that? Okay. It's 4x from there. This one? 1 over 2 root u prime. So the u prime of what we subbed in for u. Why are we even doing this? That's how you have to take the derivative of this function because there's stuff inside now. It's not just one term. Yes. Yeah, it's not just one term. And it's not, there's no coefficient either. We've only done, before today, we've only done square root x. We haven't done a square root 2x or a 3x, so we need to use this process. So it's essentially, okay, we're using substitution. Okay, we're substituting the inside. The inside, what we're subbing it in, we're just calling it a u, it's just a variable. That's all we're doing. So we're going to put this, because we can take the derivative of this. So we do that. Okay, to make our life easier than trying to do it with this, because we don't know how to do that. Right, that's good. Yep. Right, which is the derivative of the inside the function. So that's why the chain rule is the whole function derivative times inside the function derivative. Inside the radical. Right, they're the product of each other. Right. So that's what this is right here. So, see, derivative of the whole function, derivative of your inside the function. That's why they're using f and g. G is our u. G is what we're subbing in. Okay? No, because only if we were taking the derivative again.
Couldn't we just do like the last example, like the 2x plus 3, could you just raise 3x to the power 1/2 and then sub it that way? Actually 1/2 by whatever the derivative.
Right, but then you still wouldn't be getting, so wait, which one?
So like you can do like this right there, like 2 times 3, or whatever, like
this?
2x is 3.
Yeah.
And we drop this 3 down times it by the derivative of the u. Chop at that. Couldn't you just, on the root x, just put it to the power of 1/2?
Yeah.
The 1 and then times the 1/2 by whatever the derivative of the u is. And then times it by the u.
Yes. Right. So as of right now, you don't need the u because it's fairly simple. Things will get more difficult. So what you're saying is, and correct me if I'm wrong, so you're saying that this is the 1/2. Okay. So you rather put it in an exponent?
Yeah.
Okay. I mean, you can do that. Most of these I will just do the fractions just because they're easier at the end, like I was showing yesterday, but it's not a big deal that you would do that, no. So, but our last thing is we still need to get this u to be, now at that point we plug the 2x squared back in. So we're going to have this. The final answer is 4x just goes on top here, and it's going to be 2 over 2x squared plus 3 in the root. And then we can simplify the 4 over 2 to be 2x over. So this would be f prime. Okay. You have to do it anytime you have an exponent with something inside. So it's anything to an exponent. Now the reason we don't have to do it for a single x is because what's the derivative of a single x? It's 1. See, we don't have to do it. But if it's 2x, 3x, those type of things, we have to do it. Okay. Distribute the exponent amongst the terms.
Yeah, like for this one, how it's a radical, like that's equivalent to an exponent of 1/2.
Right. I was telling you, you still can do that.
Oh, you can.
Right. You still can do that. It's just, but you're still you still have to make this your u because that's still inside. So when you take the derivative, you'd still do the 1/2, like Austin was saying. That would make this be a negative 1/2, which pushes it down. So I mean, it would be the same thing. Okay. You can do like Austin was saying. Good. Any other questions? Example 1. Mind numbing. All right. So let's try 2. Okay. So we're doing u10 plus u5 plus 2. And see what they're doing here is they're giving us what u is. So it's kind of like they're giving us past step 2 already. we want to find the derivative. Remember, dy dx means derivative with respect to x when x is 1. So all we're going to do is we're going to take the derivative of each spot. But since we have u already subbed in, remember, when we do this, they're doing this problem's on purpose to make you realize you take the derivative of the thing and what's inside the thing. So what's the derivative of u10? 10u to the 9th, but we have to multiply it by, what's the derivative of the inside the u? Like the u itself. Negative 6x. I know you're saying u's and x's. We will sub the u back in eventually. Somebody know? Okay. Second. Okay, so continuing, take the derivative of the second term. That's going to be what? 5u to the 4th, again, negative 6x. Because it's the same u. And derivative of 2 is 0, so we don't have to worry about that. That's done. Okay, so now at this point, we can pull a negative 6x out because they both have one, just to make things a little simpler. Whoops. Okay. And then from here, you can insert this if you want, or we can just go ahead and plug the 1 in now if we want to figure out what it's going to be. So we're at the point, because we have the derivative, correct? This is the derivative. This is y prime right here. So even though they're u's, like I think I'm going to go ahead and write it just for right now. I'm going to go 10 times 1 minus 3x squared to the 9th plus 5 times 1 minus 3x squared to the 4th. And then I'm going to insert now in all my x's a 1. Okay, so that gives me negative 6 times 1 is a negative 6. 1 squared is 1. 1 minus 3, so I'm going to have 10 times negative 2 to the 9th plus 5 times negative 2 to the 4th. Okay, and at this point, it's just a calculator, a little calculator work. You can put this into your calculator here, and it's going to get you this kind of big number here of 30,240 for this example. It just ends up being a bigger number. Sorry, I do commas still.
So what is that number?
That number would be still what the slope would be at 1 for that problem. Because that's to the 10th, so it's a very interesting formula. It's still our derivative, so it still holds the same definition. So at 1, that's our slope going through this line. So if you put that in your calculator, in your graph calculator, I imagine it'd be a very, very steep spot at 1, and so it'd be a very steep slope, would be my guess. Okay? All right, we've got 2 more just for today. All right. All right, so with that said, all right, so the power rule combined with the chain rule. So this is just talking about when you have to do them together. So if n is any real number and u is g of x is differentiable, then, so that just means n is in your exponent. You still will drop. So n minus 1 means you drop an exponent, you drop the n, and you take the derivative of u. Just another way of writing what we've been doing. Okay, so drop the exponent, keep the middle. That same thing to the minus 1, wherever you dropped your exponent, and the derivative of the middle. So the power rule, they want you to see the power rule, which is our lesson 2, of just dropping the exponent, subtracting 1, keeping the middle, and then take the derivative of the middle. So essentially what we've already been doing. It's not a big deal. Okay. All right, so example 3. Find dy dx. Okay, this is very straightforward, very simple, because only so far you can go. Okay, when you get to the point where you don't have to use u's, but when you get to really, really hard stuff, it does help. We can, just for the purposes right now. So our u is x squared minus x plus 2. Sorry, I kind of ran out of room there. So that means our equation would be y equals u to the 8th. Again, you don't have to use the u's if you don't need to, but okay. So sometimes when I do this, I go and just figure out what my u prime is right now. My u prime is 2x minus 1. And I just kind of write that there because I know I'm going to take the derivative of this and then have u prime. So I'm going to have y equals 8u7 u prime by our definition. So now when I plug everything in, this is what I get. 8 x squared minus x plus 2 to the 7th times 2x minus 1. And that's as far as you can go. Now, if they gave me something to evaluate at, I could. But that's as far as you'll go. The next one, Garvey, we're going to do your way. Okay, go ahead and try this one on your own. Okay, using, like I said, I would use kind of what Garvey's been talking about, try to put everything into your fractional exponents. This is what I would do if I was you. Okay, I'm going to pause the video for a second and let you guys. Okay, all right, so with this one, the first thing we want to do to try to make our lives a little bit easier is we want to do f of x to us should be 1 minus x to the 4th to the negative 1/3. Now my u is 1 minus x to the 4th. My u prime is negative 4x cubed. All of you seem to have a pretty good grasp on that. So that's good. Okay, now it's just kind of fraction work. So what I want to do is I'm going to do f prime. Remember, it's going to be, the way they write it, it's going to be f of g of x prime. That means the whole thing. I'm taking the derivative of that. And then g prime. That's what we're doing. So I need to take the derivative of this and then the inside, which we already have right here. Okay, to derivative of this, I drop the negative 1/3. That's the power rule. 1 minus x to the 4th. So I drop the negative 1/3. I minus 1 from here. Okay, that gives me negative 4/3. That's the derivative of the function. Now derivative of the inside, negative 4x cubed. Okay, now, since that's a negative exponent, bottom, 3 is on the bottom. Think you have a negative times a negative. You do. So you have a negative 1 and a negative 4 here, so it's going to be a positive on top. So I saw that being a mistake on some of you guys. So you should have 4x cubed on top. That on bottom with a 3 in front. So most of us were pretty dang close to that, so that's good. Okay, questions on that? Yeah, Emily? So I have a negative 1 here. Remember, these are the products, right? Negative 1 and a negative 4 makes a positive 4. So the negatives just cancel at the top. See right here? And this negative went to the bottom to be positive. Right, I just dropped, yeah, exactly. I dropped this down, okay, and then I multiplied these two for the top. That's what, say that again. Right. Okay, anything else? Okay, that's a wrap.
So like if you were given a point now,
You plug it in.
the point would just
plug it in. Yep, because this is the derivative. We have the derivative.